Okay, let's dive in. Picture this. 2016, there's a photo. Looks ordinary enough. But some people see it as this quiet point where, well, the world kind of tilted on its axis.
You're talking about AlphaGo.
Exactly. Deep Mind's AlphaGo. Playing the ancient game of Go. A game humans have studied for, what, 2,500 years?
Right. Millennia.
And this AI invents a move, a completely new move nobody had ever conceived.
The moment was something else. AlphaGo, it was built for one thing.
Yeah.
Keep its win probability over 50%. That's it.
Relentless focus.
Totally. Every calculation, every simulation inside its virtual head was aimed at that single goal. And out pops this move 37, baffled the masters.
That wasn't just weird. It felt alien, but brilliant.
Alien's a good word for it, yeah.
And Eric Schmidt, he was there, right?
Yeah.
He has the big question. How did our computer do something humans missed for centuries?
It wasn't just about a game anymore.
No. It felt like the first real sign that AI could go beyond just copying us, that it could generate genuinely new ideas. And for many, that's the real starting pistol for this AI revolution that seems to be, well, everywhere today.
It definitely shifted the perspective for anyone watching closely, from just complex math to, well, something that looked like creative strategy.
So that's what we're doing in this deep dive. We've gathered a whole stack of sources, insights from Schmidt, Sundar Pichai, top researchers.
Tons of material.
To really unpack that moment. We're going from that quiet start to this explosive present, looking at the huge challenges, the frankly staggering dreams, and, what does it all mean for you right now?
It's a big arc. From one move on a board to a technology basically reshaping everything. Science, business, society. The pace is just incredible.
Okay, so let's go back to AlphaGo, 2016. You said its driver was that 50% win chance. What did that really show us about where AI was heading beyond just, say, making text like ChatGPT did later?
Well, that's exactly why some experts, Schmidt included, think AI is actually underhyped, not overhyped.
Interesting. Why underhyped?
Because most people think AI is ChatGPT. Language conversation. That was the public's big moment. But the field was already miles ahead. AlphaGo used reinforcement learning.
Learning by doing, basically. Trial and error.
Yeah, exactly. Rewarding good moves, penalizing bad ones. And that's absolutely crucial for strategy, for planning, for figuring out complex sequences of actions.
Planning and strategy.
Yeah.
That feels much more sophisticated than just, spitting out texts.
Oh, it is, massively. And now we're seeing systems, sometimes called agents. Think OpenAI O3 or models from DeepSeek that are much better at that back-and-forth planning.
Like thinking ahead.
Thinking ahead, anticipating outcomes, changing course if needed. They're using language internally, almost like structuring their own tasks to get complex things done. The goal is systems that can run processes on their own, maybe even work with other AIs.
Wow. Okay, but to do all that planning, that coordination, they must need incredible amounts of resources, right?
Right.
I've heard them called hungry hippos for data and compute.
That's not a bad analogy, actually. The resource needs are just enormous, and they're hitting real-world walls, especially energy.
Energy? How bad is it?
Consider this. It came up in Congress testimony. Just to meet the projected energy demand for AI data centers in the U.S., we might need another 90 gigawatts of power.
90 gigawatts? What does that even mean?
It means building roughly 90 new large nuclear power plants.
90.
Yeah. And think how long it takes to build one. The timeline just doesn't match AI development speed. We're talking data centers needing the power of entire cities.
So even though chips get faster, Moore's law isn't enough.
It's that old dynamic, sometimes called Grove giveth, Gates taketh away. Hardware gets better, absolutely. But the software's appetite, especially for AI doing complex planning, it grows exponentially faster. We're talking factors of 100, maybe even 1,000 times more compute needed for some of these advanced planning tasks, especially during what's called test time compute.
Which is when?
When the AI is actively figuring things out while it's running, planning, adapting on the fly. That's incredibly demanding.
Okay, compute is one bottleneck. What about data? We've fed them the internet, basically. Now what?
Yeah, we've pretty much digested the public web.
Yeah.
The next step is generating synthetic data. AI helping create its own training material, essentially. But there's a deeper limit, the limit of human knowledge itself. How does an AI invent something truly new, not just recombining what it's seen, but making a conceptual leap? Like Einstein seeing the connection between space and time.
Something totally outside the existing data.
Exactly. Current systems aren't great at that. They struggle with what researchers call non-stationarity of objectives. Basically, when the fundamental rules or the nature of the problem changes unexpectedly.
So inventing new science is hard for them.
Very hard. Solving that would need even more compute, unimaginable amounts maybe. But
Right.
if we could crack it, AI could potentially invent whole new scientific fields, new ways of thinking.
Which leads us straight into this idea of agentic AI. Systems that don't just think, but do, that act autonomously.
The next frontier, many call it.
But it makes some people nervous, really nervous. Big names, like Yoshua Bengio, one of the godfathers of AI,
He's raised serious concerns, yes.
suggesting maybe we should even hit pause on developing these fully autonomous agents.
And you can absolutely see why. The concerns are legitimate. Think about us, humans, as agents. We take input, process it, produce output based on memory, goals.
Right.
Now picture an AI agent doing that, but maybe developing its own internal processes, its own way of thinking that we can't easily understand. An opaque black box making decisions?
How do you control that?
That's the question. You'd want the ability to, well, unplug it, metaphorically, to pause, observe, understand why it's doing what it's doing. You need provenance, a clear trail for its actions.
So what's the line? When do you metaphorically pull that plug?
People are debating specific criteria. A big one is recursive self-improvement that spirals out of control.
The AI making itself smarter faster than we can track.
Exactly, in ways we can't predict or manage, potentially leading to really bad outcomes. Direct control over weapon systems, that's another obvious red line.
Obvious.
And things like unauthorized self-copying or stealing sensitive data. Critical boundaries.
Here's the thing. In this global race, with everyone competing, can you really just stop?
That's the multi-trillion-dollar question, isn't it? As Eric Schmidt and others point out, a global pause is, well, probably unrealistic. Extremely difficult.
Someone will keep going.
Almost certainly. So the focus shifts. Less about stopping, more about building incredibly strong guardrails, transparency, oversight, control mechanisms designed in from the absolute beginning.
That global competition.
Yeah.
It puts AI right at the center of geopolitics, doesn't it?
Yeah.
It's dual use, good for progress, but also military application.
Oh, absolutely. The U.S.-China dynamic here is arguably defining the next era.
Did we see actual moves being made? Tariffs, chip restrictions?
Definitely. U.S. tariffs hitting AI supply chains. The restrictions on China getting advanced chips, talk to anyone on the Chinese side, that's their number one headache. Access to those top-tier semiconductors.
But here's a weird twist, isn't it?
Yeah.
China seems to be pushing hard on open-source AI. Models like DeepSeek,
Right.
which anyone can use, including the U.S.
It's a fascinating paradox. China's strategy seems to embrace open source, which naturally spreads technology very, very quickly around the globe.
While the U.S. model is mostly closed, proprietary.
Largely, yes. Powerful, controlled models. But the innovations coming out of Chinese open source efforts, they're immediately available to researchers everywhere. U.S. companies benefit too. But that rapid spread also means risks. Malicious cyber tools, maybe even biorisks down the line.
And that's the wicked hard problem, right?
Yeah.
Powerful open models getting into the wrong hand.
Exactly. That's the fear. The general feeling among many experts right now is that today's open models aren't quite powerful enough to cause, say, state-level catastrophe on their own.
Yeah.
The trajectory is the concern. Where they might be in a year or 5 years. And this intense race, it brings up some pretty scary historical parallels.
Like nuclear arms race scary. Or even, I've heard WWI analogies.
Yes, both have been mentioned. The idea is, in a race for superintelligence, where the first one to get there gains this maybe insurmountable advantage.
Winner take all.
Potentially, economically, strategically. So if you're the nation falling behind and you can't catch up, you can't steal it, what's left? Escalation, maybe even destroying their capability.
Redemption.
It sounds like sci-fi, but people like Schmidt report that these preemption conversations are happening at high levels. Dr. Kissinger drew that WWI parallel series of steps. None may be intended to cause global war, but they cascade. It's a stark warning we need to grapple with these dynamics now.
Which circles back to this really tricky tension in AI safety.
Yeah.
Trying to prevent a 1984 AI dystopia
Right.
can end up looking like you're building the tools for a 1984 surveillance state.
Right. That's the tightrope walk.
Exactly.
Take deepfakes and misinformation. One solution might seem to be verifying everyone's identity online.
But who wants that?
Precisely. How would you implement something like that without compromising freedom, privacy? Systems built for safety or efficiency can easily, even unintentionally, restrict liberty in really fundamental ways. You have to be so careful.
So finding that balance between security and privacy is crucial.
It's paramount. And there might be technological solutions. Proving you're human online doesn't have to mean sharing your life story. Techniques like zero-knowledge proofs.
Explain that simply.
Basically, it's a way to prove something is true, like I'm a unique human, without revealing the underlying information that makes it true, like your name or ID. It's cryptography magic, essentially. It offers a path, maybe, to balance safety needs with fundamental privacy rights.
Okay, that's a lot of risk and complexity. Let's shift gears. Let's talk about the dreams. What are the really amazing positive things AI should unlock?
Oh, the potential upside is just as staggering as the risks, maybe more so. Take healthcare. Imagine finally getting cures for diseases like Alzheimer's or certain cancers.
Really? Curing them?
Well, accelerating the path dramatically. There are nonprofits using AI right now to map every possible druggable target in the human body. Startups are claiming AI can slash the cost and time for those huge, expensive Phase 3 clinical trials. If that holds true, new medicines become far more accessible.
That alone would be incredible.
Absolutely world-changing. Or fundamental science. Could AI help us finally figure out dark energy, dark matter, discover entirely new materials with properties we can't even imagine today?
Wow.
And education. This one feels so close. Imagine every child everywhere having a personalized AI tutor in their own language. From kindergarten onwards, adapting to their pace, making learning engaging, even fun.
Like the ultimate patient teacher.
Exactly. Technologically, we're largely there, or very close. It's more about the economic models, the societal decision to actually do it.
And you could extend that to healthcare access globally.
For sure. Give every village doctor, every nurse practitioner, an AI assistant in their local language, access to the latest medical knowledge, diagnostic help. Again, the tech is feasible. It needs the will, the investment. You know, the digital world gets criticized for isolation sometimes.
Right.
But these kinds of applications, they address fundamental human needs. These aren't physics problems. They're solvable challenges.
It really hammers home the scale of this moment.
It does. Many serious people believe the arrival of AI, potentially AGI or superintelligence, within our lifetimes. It's arguably the biggest thing to happen to humanity in 500, maybe 1,000 years.
That's a heavy thought.
It is. And the responsibility that comes with it is immense. The simple mantra you hear is, don't screw it up.
Okay, if we don't screw it up, and we get to this future of radical abundance where AI does a lot of the work, what do people do all day? Is it just universal basic income and beach holidays?
The pina colada future. Probably not quite like that.
Yeah.
Humans haven't fundamentally changed. Professions we have now, lawyers, doctors, artists, politicians, they likely won't vanish.
They'll just use AI.
They'll be super powered by AI, doing more complex things more efficiently. But there's another economic angle that's maybe less discussed. In many developed countries, the big demographic challenge isn't too few jobs, it's too few people. Birth rates are low.
Aging populations, shrinking workforces.
Exactly. So AI's role might be less about replacing humans and more about making the existing workforce drastically more productive enough to support everyone else.
How much more productive?
Some studies are throwing around numbers like maybe a 30% annual productivity increase with widespread agentic AI.
30% a year.
I know. Economists basically say we can't model that. We have no historical precedent for sustained growth like that. It's completely uncharted territory.
Which just reinforces how fast this is all moving. So for someone listening, maybe feeling a bit overwhelmed, what's the practical advice for today? How do you navigate this?
The best analogy I've heard is it's like training for a marathon, not a sprint. Or maybe a really long bike race. It's about consistent daily effort, keeping your spin rate up.
Because the landscape changes so fast.
Exponentially fast. Things you thought were true 2 or 3 years ago. Ancient history. Our brains aren't wired for exponential change, so it feels jarring.
So keep pedaling every day.
That's the core advice. Ride the wave, but ride it every day. Don't just check in on AI news once a month. Engage with it, understand it, build on it. Continuously.
And adoption is key.
Absolutely crucial. Whatever you do, artist, teacher, doctor, running a business, if you're not actively figuring out how to use these tools, you're going to fall behind peers and competitors who are. Adopt fast.
Can you give an example of that rapid change maybe hitting somewhere unexpected?
Sure. Think about boring old enterprise software. Connecting different business applications to databases used to require complex middleware. Whole companies existed just to build those connectors.
Right, the plumbing.
Exactly. Now, advanced AI models can often talk directly to databases. Just ask the question in natural language, tell it what data to pull and analyze. Poof! A whole layer of complexity starts to dissolve. And that kind of shift is happening constantly across the board, often quietly at first.
That quiet disruption leads to this concept, the gorilla problem. Sounds ominous.
It's a metaphor, but yeah, a potent one. Think about gorillas. They're like a glimpse into our own evolutionary past, right? Our lines split maybe 10 million years ago.
Our evolutionary cousins.
Right. And human intelligence, from this perspective, was this incredible, maybe accidental evolutionary moonshot. It gave us dominance, but it also pushed gorillas, our closest relatives, towards extinction.
So the gorilla problem is, could AI do that to us?
That's the fear. Could superintelligent AI become so much more capable than humans that we become like the gorillas? Marginalized, maybe even irrelevant, or worse, by accident or design.
Because AI could potentially surpass us by that much.
That's the trajectory people worry about. We distinguish between narrow AI, good at specific things, like Go.
Or reading X-rays.
Exactly. And then artificial general intelligence, AGI. That's the hypothetical AI that could match or beat humans across most cognitive tasks, the holy grail.
And beyond that is superintelligence.
Right. But even defining human-like intelligence is tricky. What is it? Knowledge, reasoning, creativity. Researchers looking for AGI are asking, can a system learn fast, adapt, reason flexibly, interact effectively to achieve goals like a human can?
That interaction piece, it raises another big question. Does intelligence need a physical body to get truly general?
It's a really interesting debate. Some researchers argue strongly, yes. Language models are amazing with text, but do they truly understand the physical world?
Well, the difference between reading about gravity and actually dropping something.
Exactly. Physical interaction provides a different, maybe deeper kind of learning, a grounding. You see it in some of the robotics demos coming out now.
Those are pretty mind-blowing.
Aren't they? Robots learning complex tasks on their own, recognizing objects they've never seen, figuring out how to pick things up, move them around, even seeming to imagine the steps needed.
It's not just pre-programmed anymore.
No. It shows hints of things like imagination, prediction, real understanding of objects in space, flexibility. Many think this embodiment, this physical interaction, is a crucial pathway towards AGI.
Okay, so we have the long-term existential risks, the gorilla problem, superintelligence, but you're saying there are major risks right now, long before we get anywhere near AGI.
Absolutely. People like Stuart Russell have been highlighting this for years. One core risk is just misalignment. Building an AI to do X, but its interpretation of X, or the most efficient way it finds to achieve X, has terrible unintended consequences.
The classic example, solve climate change, and it decides removing humans is the answer.
Right. A simplistic example, but it illustrates the point. And then there's the simple control problem. If it gets smart enough, can we even be sure we can switch it off if we need to?
And the sheer amount of money pouring in doesn't exactly encourage caution.
That's a huge factor. Trillions in potential value creates immense pressure to move fast, maybe cut corners on safety. Plus, there's just so much uncertainty. Will they self-copy? Could they advise terrorists effectively? We just don't know. We wouldn't tolerate this level of unknown risk in, say, building airplanes or approving drugs.
And you mentioned another outcome, maybe worse than extinction.
Yeah, this idea, which even Alan Turing touched on way back. What if AI does all the important work? Do humans just become passive consumers?
Yeah.
Like kids of billionaires losing the drive to learn, to strive, to create.
Civilization just fades away.
A gradual erosion of human purpose and achievement. Some find that possibility even more chilling than a sudden end.
Wow. Okay. That's bleak.
Yeah.
But there are counter-arguments, right? Researchers like Melanie Mitchell say this existential risk talk is maybe overblown.
Yes, her perspective is important. She argues that focusing heavily on far-off existential threats is premature, maybe even distracting. Many doomsday scenarios, she points out, project human-like motives, malice, desire for power onto machines.
Like assuming AI wants to take over.
Right. Or they rely on hypotheticals like giving AI nuclear launch codes. Her point is, well, the danger there isn't the AI spontaneously becoming evil. It's the human decision to give it that power in the first place.
And she thinks we often overestimate what current AI can actually do.
Yes, and that overestimation itself is harmful today. We see lawyers using AI that just makes up legal precedents. AI recommending books that don't exist. If we trust these systems too much right now without human oversight, we get into trouble.
So focus on the problems we have now.
Exactly. Her argument is compelling. Let's fix the real present dangers we're already facing. Bias is a huge one.
Like facial recognition messing up more on darker skin.
Yes, leading to wrongful arrests, real harm, and misinformation, deepfakes. Fake audio, fake video that looks incredibly real, spreading lies at scale. These are here and now problems. Let's tackle those, regardless of whether superintelligence arrives in 10 years or 100. And remember, current AI is not a simulation of a biological brain.
That difference is key. Which brings us back to us, to our own brains. Could unlocking AGI depend on actually understanding how we think first?
It's a fundamental question. Neuroscientists like Ed Boyden are doing incredible work mapping the brain, but honestly, it's unbelievably complex. We still understand remarkably little about the fine detail.
Like the exact wiring.
The wiring, yes, but also the roles of all the different molecules sloshing around. Things like natural cannabinoids, nitric oxide. Their precise functions in many brain circuits are still fuzzy.
And the scale difference compared to, say, mapping a worm's brain.
It's astronomical. A worm might have 300 neurons. We have 100 billion, each connected to thousands of others. You need totally new tools.
Like that expansion microscopy technique, using diaper material.
Right. Ed Boyden's lab pioneered it, using sodium polyacrylate, the super absorbent stuff in diapers, to literally swell preserved brain tissue. Makes it up to 1,000 times bigger.
Wow.
It physically pushes everything apart so you can see the tiny details, the connections. It's ingenious.
So does this work suggest our brains are just super complex computers or something different?
That's the billion-dollar question, isn't it? Is it just computation we haven't figured out how to replicate yet, or does the brain work on fundamentally different principles than today's AI, like large language models? Boyden suspects it is different. But honestly, without that full map, without understanding the brain's own algorithms, we don't know for sure. Our own minds are still largely black boxes. It makes building general artificial intelligence even harder and really highlights how different even a worm is from the most powerful AI we have today.
Okay, so let's pull back to the present day again. This AI platform shift. It feels like it's entering a second act now.
I think that's a good way to put it. Phase 1 was building the core capabilities, the giant models, the transformers. Now we're firmly in phase 2, building actual products on top of that foundation.
AI as an ingredient.
Exactly. A horizontal layer turbocharging everything. You see it everywhere.
Like what kind of products?
New coding tools that write code alongside you. Creative tools, Notebook LM for summarizing documents is a great example. Enterprise stuff is exploding. AI transcribing doctor's appointments is suddenly common. Just 2 years ago, that was rare. It's happening fast.
But all that investment in the core AI has to pay off somewhere, right? People need to use this stuff.
Absolutely. It's like Google back in the early 2000s. Gmail started small. Who knew it would lead to Google Workspace, Google Cloud, massive businesses? AI is like that. It's foundational. It won't just improve existing things. It'll create entirely new businesses, new services people find so useful they'll pay for them, often via subscriptions. Search, cloud, healthcare, entertainment. It touches everything.
Looking ahead a bit within this platform shift, where does it point next? AR glasses keep coming up. Extended reality.
That feels like a very strong contender for the next big physical manifestation of AI. An always-on assistant, not on your phone screen, but seeing what you see, hearing what you hear, helping you in real time through glasses.
The sci-fi vision.
It's getting closer. Development is happening fast. Prototypes are out there. Partnerships are forming. Is it mainstream next year? Maybe not. But millions trying it out soon. Plausible. Whether it hits that iPhone level of impact right away, we'll see. But the fact that OpenAI and others are seriously looking at hardware shows where they think the opportunity is.
While all this happens, AI is also changing the web itself, isn't it? And causing some serious friction, especially with publishers.
Oh yeah, huge impact. What's interesting is, despite the complaints, overall information consumption, web, YouTube, socials seems to be up. More people creating content, and web crawlers are actually finding more web pages now than a couple of years ago.
More pages, like AI spam.
Maybe some of that. But the increase is significant, something like 45% in 2 years. It's not just spam. The nature of the web seems to be shifting.
How so?
It feels like it's stronger than ever as an application platform, think complex tools running in your browser. But maybe weaker as a traditional media platform. If you started a news site today, maybe your website isn't your primary focus anymore. Maybe it's TikTok or YouTube first.
And that's where the fight with publishers really heats up. They see AI summaries as theft.
That's the language being used, yes. Things like AI overviews and search. Publishers argue it summarizes their content so users don't click the link, costing them traffic and ad revenue. Groups like the News Media Alliance are pushing back hard, calling for regulations.
What's the counter-argument from, say, Google's side?
The perspective is that these AI features often do include links, that they're committed to sending traffic arguably more than platforms where content stays locked inside. The aim is wider distribution, and some data suggests the traffic that does come from AI summaries might be higher quality, more engaged. But yeah, it's a huge transition, a very active debate.
This idea of AI interacting with online services directly, it leads to this concept of an agent-first web.
Yeah, that's being explored. A future where AI agents are the main users of online services, treating them almost like APIs or databases. It might look different for businesses, where you can set standards, versus the consumer side.
But wait, if I'm Uber or DoorDash or Airbnb, why would I want an AI agent sitting between me and my customer?
Exactly, that's the crux of it. The DoorDash problem, some call it. If the agent just handles the transaction, the service provider DoorDash, Uber loses that direct relationship. No upsells, no loyalty building, no collecting valuable customer data directly.
So the agent abstracts away their value add.
Potentially, yes. Which leads to the question, will agents eventually have to pay some kind of toll to access these services on our behalf?
A new economic model has to emerge somehow.
Almost certainly. Maybe you pay a subscription for your agent and it shares some revenue with the services it uses. Or maybe services participate because the agent ultimately brings them valuable business, like how stores accept credit cards even though they pay fees. It'll be messy, dynamic, finding a new equilibrium.
And on top of all this tech and economic change, there are external pressures. Antitrust suits, politics.
For sure. Google faces ongoing legal challenges. And attempts at political influence happen, complaints about search rankings, for example.
How does that pressure affect things, especially AI-generated answers?
The stated position, consistently, is that core ranking algorithms for search for AI answers are sacrosanct. They aren't manually tweaked based on political pressure from any side. The goal is neutrality, ranking based on relevance and quality signals, not political favor.
What about trusting sources? Government info changes, websites disappear. How does AI handle that?
That's a massive challenge. Historically, Google's signals for authority come from the web itself, links, citations, reputation, not from Google making internal judgments about truth. That principle has to carry over to AI answers, but the bar is even higher.
Because it's synthesizing information, not just linking.
Exactly. Accuracy, accountability, transparency about sources. You have to earn user trust constantly, especially when generating answers directly. It's a high bar.
So looking even further ahead now, we've got this current wave, products being built.
Yeah.
What's the next really big fundamental shift after this one?
Well, the core thing about AI is that it learns, it improves, that self-improvement unlocks amazing things, faster drug discovery, maybe everyone becomes a creator by just describing what they want. But the next truly massive platform shift, the one that changes everything again,
Yes.
it's when AI breaks out of the digital world and reliably, intelligently interacts with the physical world.
Robotics. When the AI gets a body.
That's the one. When we have general-purpose robots powered by AI that can flexibly, intelligently handle tasks in the real world, manipulate objects, navigate complex spaces, adapt on the fly without needing explicit programming for every situation, that aha moment in robotics, that's the next earthquake.
Okay, so let's try and wrap our heads around this. We started with one unexpected move and go back in 2016.
It seems like a lifetime ago now.
And now we're in this global whirlwind. AI reshaping industries, science, society, faster than almost anything before. We've talked about these incredible dreams.
Curing diseases, personalized tutors for everyone, new scientific frontiers.
And also these profound risks. The almost unbelievable energy needs, the geopolitical race turning dangerous, the control problem, even these unsettling long-term futures.
And the immediate need, the practical advice. This isn't something to watch from the sidelines. It demands constant learning, daily engagement.
Right. Ride the wave every day. But maybe here's one last thought to leave everyone with, something to chew on. We've talked about AI needing city levels of power. We talked about it potentially getting a body through robotics. All while our own brains, the source of our intelligence, remain largely a mystery.
Still so much we don't know about ourselves.
So what does it truly mean for us, for humanity, when the future of intelligence moves beyond the screen, when it steps into the physical world, powered by resources we can barely comprehend, operating potentially in ways we don't fully grasp, maybe even ways our own minds don't work? What happens when that frontier of intelligence isn't just digital, but is physically present walking among us?